Hey everybody, this is Alex Merced from alexmercedcoder.com, and what I want to do is continue talking about Go, and here I'm just going to talk about a concept that if you've done C or C++, you're probably very familiar with, pointers, okay? Always been, I don't know, I always found pointers to sort of be a thorn in my side just because you got to keep track of where your pointers are pointing, okay? But what a pointer is, it's a variable, and we kind of talked about this when we talked about slices, because slices are essentially an array of pointers. It's pointing to a spot in memory, not pointing to the value itself. So essentially, if let's just do an example. So let's see here. Let's say that num1 equals 5. So I have a variable, it's going to be an integer value that equals 5. Okay. Then I'm going to create a pointer. I can put an asterisk in front of it, and we'll say num2 equals. Okay, and I'm shorthanding it, so we'll see if I shorthand it, does it work without having to declare the whole pointer first and longhand. So let's see here. Pointer num2 equals, and then you want it to equal the address of the variable. So I want it to equal the @ sign means address of variable. So the address of num1. So the asterisk means this pointer, this num2 is a pointer, and it's going to equal the address of num1. And then I'm going to hit format print, and we're going to print num2 and see what happens. Okay, num2 defined. Yep, I'm going to have to define the. I didn't want to use the quick assignment operator. The only difference is I don't need the asterisk. The reason being is that since I'm assigning it the address of num1, it's inferred that it's a pointer, so it'll figure that out. And I'll show you the longhand way in just a moment, but let's run that. Okay, and you see what's inside num2 is not the value 5, but a reference to the spot in memory where the number 5 exists. Okay, where num1, the variable num1 exists. So if I go back, and then that can change every time the program runs because the program's constantly seeing where the memory is. Okay, cool. So now what happens, I want to take num2 and say it equals 6. And instead of printing num2, we're going to print num1. So by changing num2, does it automatically change num1? It should, it's a pointer. So let's see if that's the case. Okay, so this is when I want to actually specify with the asterisk. Now the reason being is that when I don't put the asterisk and I assign something like I did here, what I'm assigning is an address, because it's like, oh, okay, you're assigning an address to this pointer variable. Now, basically when I put the asterisk, I'm saying, hey, for the purposes of this instance, point to the variable. We're talking about the value of where you're pointing at. Okay, so which then actually begs the questions. Well, first let's run this. So technically this should turn it to 6. So let's try that out. And there you go. So you see num1 was originally 5. We created a pointer that pointed to num1. And then we changed the value of where this pointed to using the asterisk symbol to 6. And then we printed num1, and num1 is now 6. Okay, so we changed num1 without touching num1. Cool. Okay, so let's do this. Okay, actually, I want to keep that. I'm going to delete this for a moment. I want to see the difference if we do this versus this. Okay, so if we run that, okay, so you see what happens. Now again, the way this console runs, it doesn't put spaces between the prints, but see, that's the memory address. Okay, and then it prints the value of num1, okay, 5. So again, when you don't have an asterisk, it's referring to the address stored in the pointer variable. Okay, versus when you do put the asterisk, you're referring to the value where you're pointing. So keep that in mind. I want to make sure that's very clear. Okay, but now if I wanted to declare this the long way, so if I wanted to declare num2 the long way, the way it would work is I would say I'm creating a new variable, Okay, and we're going to call it num2, and the type is asterisk, meaning it's an int pointer. That's how you know the difference between a pointer. So again, that's the thing you always got to be careful for. So again, this means it's a pointer, this means it's a slice, this means it's an array of 3 places. Okay, so these are all the different, well, int. So those are all the different ways you can take that same type, int, and then expand upon it. Pointer, slice, array. Okay, so syntax. So let me put my asterisk back there. Okay, and now, oh, it needs reloading. We'll let it reload, but again, we're pointing to the value, which can then be used and mutated and whatnot. And you can do this with really any data type. You can make string pointers, array pointers, and one of the benefits of doing this, okay, it looks like I'm having an internet issue, so I'll pause this until that reconnects. We're back in action. So that is sort of what pointers do, okay? Now, what are some interesting things you can do with pointers, okay? One thing we can do with a pointer is you can point to a variable that's used within a function, so you can access a variable that's created within a function outside the function, okay? So let's see here, let's do something like that. So let's say, okay, func, we'll call this pointer play, and it is going to take one parameter called point of type array integer. Okay, cool. And so basically it's an int pointer, I mean. Cool, and it's going to return an integer pointer. Okay. Now what I want to do is we're going to create a variable, so we'll call it the num1. So we're going to say num1 equals 5. Okay. Cool, and then point will equal the address of num1, and then I want to return num1. Cool. Well, not num1. I want to return point. So essentially, even though it creates a variable within the function which should have a local scope, I should still be able to go back and retrieve that value because I have the I walked away with the address where that item was stored, and then since the pointer is referring to that address, the garbage collector won't destroy it. At least theoretically, that's what I'm imagining should happen. So let's see if that's the way this works. Okay, so first let's create our pointer. Var my pointer, which is of type int. Okay, and then we're going to use our function pointer play, which again takes as a parameter my pointer, again a pointer of int type. Let's see here. What I may need to do is just in case. Let's see what happens. So let's see here. In that case, if I now print the value of my pointer, so I got a point, it should point to the number 5. I have a reason to suspect it might not, but let's see here. The reason being is that even though I'm returning the point, it may not necessarily change the value of my pointer. I may need to assign it, but we'll come back to that. Okay, or no pointer difference. Station. Okay, it doesn't look like I can do that particularly. I thought that would be a neat trick, but I guess not. Okay, so the issue seems to be having is that I cannot point to that memory address because it's empty, which means it did garbage collect. So that means when the function ran, okay, I got the memory address, but the memory address I'm pointing to has nothing inside of it. Now let me test one other thing out, because it might not be pointing to the address I think it is. So what I'm going to do is I'm going to do this. My pointer equals pointer play my pointer. So I wanted to return that returned pointer. Okay, so basically see if that makes a difference. And that made the difference. Okay, so to explain what happened here is that technically when the function ran, so while I returned the address to that number 5 created by my function, I never assigned it to anything. And just because I played with the pointer, because again, when a function runs, it makes a copy of your parameters. So your parameters aren't really changed, for the exception of when you're playing with slices. Okay, because again, the slice is a pointer to the array. So what you're doing is you're technically modifying, it's pointing to the same addresses of that array, and you can modify the array. And I can essentially do that here too. If my pointer that I passed through was pointing to an actual value somewhere, I could directly modify it. But that's not what I was doing here. So essentially what happened is that to fix it, so technically when I printed my pointer the second time, it was still pointing at its initial address, which wasn't the address where that 5 was stored. So what I needed to do was to take that return pointer, this thing, and then assign it. So basically when the function runs, it returns a pointer. I have to assign the value of that pointer to my pointer. Okay, and so technically I don't need this. Okay, what I could do is this. Okay, num1 equals 5. And then I could just return. I don't know, let's see here. I might need to keep it that way. Let's see here, at point. I only want to basically return the address of num1. Okay. That's not really an integer pointer. So I probably still need Control Z. The difference is I'll probably have to do this. So that way, because then since I didn't pass point as a parameter, I need to make sure that it's creating a new pointer because it has to pass back, it has to return a pointer. So that should still work. Yep. Okay, I don't even need to pass that original pointer as a thing. Cool. I would pass a pointer if there was some sort of value I wanted to change. Maybe I should do an example of that. But basically, again, I can now access this 5 that was technically created in here. And typically, when you create a variable within a function, you should not be able to access it outside the function. So the pointer allows you to sort of violate the rules of scope, which is one of the cool things about pointers, but also makes them so darn confusing. So let's do this. So let's say my pointer int took my pointer. We created a variable. So let's say so num2 equals 7. Okay, and my pointer initially equals the address of num2. Okay, so if that's the case, now my pointer is pointing to num2, which is worth 7. So now there's actually a point in me, no pun intended, in using that as a parameter. So let's go back over here and let me do that again. So we're going to say point, which is again a integer. And what I'm going to do here is I'm going to take the value of point. Okay, and actually what I'm going to do is I'm going to return nothing. Okay, see if it lets me do that. But I'm going to take the value of the pointer and make it equal the value of point, or actually I'll just increment it. That's what I'll do. Okay, just increment it. And again, it's going to increment the value of what that pointer is pointing to. So it should change the actual variable. So let's see here. Okay, so num2, my pointer equals at num2. So pointer play. So now what I want to do is just print that, or actually first run the function. Pointer play my pointer. So what it should do is take my pointer, which is pointing to num2, increment it, so then num2 should now equal 8 even after the function is done. So I'm actually mutating the variable. So format print, I want to print out num2. You have to fix some things syntax-wise, but that's essentially what we're going to accomplish, and that should work. Yep, cool. So that worked the way we expected it to. So again, I declared a variable num7, and I have a pointer that equals num2. So when I pass it into the function, even though this pointer variable doesn't change the original pointer variable, it's still pointing to that address in memory where 7 is stored. So when I increment that, it actually increments the actual value that's being stored in num2. So that's why when I print out num2, it comes out as 8. So hopefully that makes pointers a little bit more clear. Okay, it's just a way, it's basically a way to kind of get around the whole scope thing. You can create pointers that help you access the variables that are declared globally, locally. It allows you to play with memories in different ways. It's just an extra layer of abstraction that can sometimes be very mind-numbing, but hopefully this makes it a little bit clearer.